Hello everyone, I'm Alex, and okay, so real talk for a second. Every Solidity developer has been in this exact spot. You're shipping a contract once, deploying, life is good, you forget about it. A year later, somebody ping you on Telegram or on Slack. Hey mate, can you redeploy this contract on base or on any new chain? Of course, same address, obviously. And now you are digging through all folders, trying to remember which script you used, what salt you picked, and what the version of the Solidity was even installed on your laptop at that time or set up to the contract. And the new developer, another example, who joined to the team last month and you left a year ago. So, yeah, they have no idea either because nobody onboard them on it, and it's starting the same loop. What the script that previous developer used or the soul that he picked. So lucky or not lucky, I've been on the both of the side of the conversation. So basically, this pushed me to build the tool that makes that conversation never happen again. So I called this software Deterministic Deployer EVM. Basically, one command line and deterministic create to deployment. Same address on every EVM chain you can take care about, written in 100% Rust language, because I don't know, maybe I'm getting older, but I've started really caring about latency and feel the runtime of the software. Okay, so here is it how actually work under the hood. I will keep it in short, and then I will show you more examples how it's working or what you need to set up before. But right now I will explain in a high level, and then we will see live testing and live examples. So you hand it contracts, either like you have a Foundry artifact path or pre-built entry for the registry inside the repository. You pick a salt also. You list the chains you want with the simple flags like Ethereum base, like very verbose to deploy it. So this is in a high level the whole interface of the software. But the magic is the deterministic deployer proxy, if you're familiar with. I guess it's aimed more for the developers audience. So I guess you're familiar with the deterministic deployer proxy contract. So you know that it's already deployed on basically every chain. That's matter. So if not, you can find the repository in the README, and if you deploy in a new chain, so you can basically, in the same way, there is instruction how to deploy this deterministic deployer proxy. So same proxy, same salt, same init code, same address everywhere. That is basically the magic of the Create2. The hard part is not the formula. The hard part is the making sure you init code, basically the bytecode of the contract, deploy on every chain. And there is a whole story about stripping Solidity version metadata to make that work, which I will show you in a second in the live tests. Before it broadcasts a single transaction, the software, it runs a pre-flight on every chain in parallel using Crate Tokyo. If you're familiar with Rust async parallel create is Tokyo. So it's basically the package that I'm using. Is the deployer proxy actually there? So it's also checking before even to craft the transaction. So the software checking if the deterministic deployer proxy exists on this chain. Also check before is your wallet funded. So basically in the chains that you flagged to deploy, the software will check if you have enough assets. Then is the contract maybe already deployed at the target address. So it's also checking if the chains that you set up to deploy, it will check also if specific this address has code. Only then does it fan out and deploy everything in parallel. So basically all these pre-checks exist before execute any transaction. And also if the deployment pass and you set up a flag verify to verify a contract, so it pushes the source up to the Etherscan automatically while you go grab some coffee or any other drink. And also for the private keys, I'm using with the key store, and it will encrypt your private key properly. Or if you won't be roasted by Patrick Collins, so you can throw it in the .env file. Yeah. So basically, yeah, use with Keystore. It's much better for your safety. Yeah, and also different small features that basically I will present in the live tests, so you can basically see them properly and to understand yeah, in a high level how to use with the software easily without adding or modify any code. Okay, so let's see exactly the tree of the project, how the layout of the repository look. So basically we have all these documentation files, so you can take a quick view. So it's explained basically in a high level how the software is working and quick start dependencies, the commands that you can basically use, architecture, how the software built. This is I'm not going to explain. If you want, you can take basically some time to read about. The README is like very simple. It's explained. I will show you just the basically things that you need to know. There is two flows of the deployment. Okay, so you can use this pre-build. So I will show you there is a file registry that you need basically to set up the all prerequisites of the contract for deployment, or basically we can use this another flow that we are set up. We are set up the path to the contract, absolute path, and it will basically craft the transaction by existing contract. So yeah, let's go and see exactly how it's working. So obviously you need to install Rust and Cargo, and also install the dependencies. So the first command, we need to install the all dependencies and to the path that it will work. And then the first command that we will craft is with the path. So basically we will use with exist contract that on your local machine. and we will deploy it to, like, for example, 4 or 3 test nets that you can see basically how it's deploying in live, and yeah, and you can feel the latency and how it's fast. So here you can see the command. I hope it's enough zoom to read the details. Can just a little bit zoom in. So you see, I'm just like running with the logger. I'm set up debug. You can just not to set up that. Then we're writing the create package name. Then the pass to the contract that you willing to deploy. So I'm deploying just the contract of the OpenZeppelin, the ERC 4626 vault. Then I'm setting up which chain I'm gonna deploy. Then solc. Solc is very important. So you can basically pre-mine the address to the vanity address. You can also find different solutions how to mine a specific address, or just do it deterministically. If you don't care, just set up any solc, but you need to remember or store somewhere this solc. Then of course constructor arguments. Then I'm using with key store, and basically let's do also the flag verify, that it basically verify this contract on Arbitrum Sepolia. So yeah, let's add a little bit more chains. I would like to add, let's say, Sepolia base Sepolia, and optimism Sepolia. Okay, so 3 chains. Okay, let's see how it's working. So basically now we have prompt. I already set up my private keys that they exist basically right now in a key store folder. So if you don't have any, so you can create, then basically just drop some private key and set up a code. So right now I'm just exiting here. So let's continue. Let's choose this private key, then inserting the password, and then okay, right now we see the all stuff that I say, that it's checking basically if this contract exists on any chain. So look how fast it was. I even didn't finish to explain about the logger, but look how it's fast deployed on 3 different chains this contract. So basically we can go and see the deployment. So up to here, it's everything basically that I was in the beginning of the video explaining. It's do pre-flight, so it's checking if any contract that we want to deploy exists on the chain, checking if the deterministic deployer proxy also exists on this chain, if the wallet's funded, and then basically deploying the contracts, then doing verification. Because this contract already verified in so many chains, so basically the Etherscan know this contract and he already verifying. But the verification also, if it need to verify, so you will see only small part of the logger of the Foundry, how it's basically verifying and give you all logs that after the contract was successfully verified. Okay, so this is the lazy pass I'm calling. So basically you still need to do some certain setups and different things to prepare. But let's back to the deterministic deployer code, and I will show you how you can set up and literally forget forever about the deployment and basically to use every single time that you want to deploy any contract. So it will store inside the code and you can use it anytime that you need. Okay, so in this case, we are going to the file registry. So it's in source, then data, then contracts and registry. I have already some tests here and examples. So basically there is kind of two pre-built option. So one that basically you not deployed yet any contract and you don't have this transaction that you deployed. So basically you are setting up all this stuff here. So for example, I set up some contracts that it's using. So we can do is the same. So basically I can just edit some fields for example, we need to know exactly what the address is going to be. This is very important. Okay, so and of course it's depends on the salt that we are using. So the software also will check that if it's match, if the salt match the address, and if not, it's not going to do the deployment. It's important protection that you will not deploy your address with your contract with different address. So the point of this software is basically to deploy with the same address in across EVM chains. So how are you preparing? Basically, you need to know the name of the contract. It should be exist in the contract that you are deploying. So you need to set up the name of the contract that you are deploying. It's very important. Then if you pre-mine address, so you can mine any address that you want, or just to check by very simple script in Foundry what the address is going to be. Then we need a path to the contract for verification. And then we need to set up the creation code. Okay, creation code, you can also do forge, inspect, and then your contract bytecode, I think, or creation code, I don't remember. You can check in the Foundry documentation. Basically, this is very important for the thing that when you have the path, when you have the Solidity code on your local machine. This is the important field's name, address, salt, pass to the contract. Here it should be none. I will show you the another kind of sub path of the pre-build. And then if you need, of course, constructor arguments, so you need to set up here. I can show you some example with constructor. I have somewhere here or not. Yeah, so anyway, I guess you enough smart, and there is like a lot of examples in the documentation how basically you're setting up the constructor arguments. Or also you can pass the constructor arguments with the flag every time. So doesn't matter if you're set up here or transferring with the flag. So let me quickly to set up we'll mine some address to show you how exactly it's working, and we will run the basically command to see how it's deploying. Okay, perfect. I set up the all contract spec. So you can see name is the here C4626 mock, that the contract that I was deploying before, just in another flow with the path and not the pre-built contract. Then basically did some vanity address. I did just 4 zeros before, and basically the salt that we are using, the pass for the verification, deploying TX right now, no, because we yet not deploy this contract with this address. After that, I will show you basically how to use with the only deployment transaction. Of course, the constructor args, and the creation code. So let's run and see how it's basically running with the pre-built flow. So the command will look like that. So basically we are already set up all necessary information, the path, the solc. So this command gonna be like much shorter, but as you can see, I'm not apply the path of the contract. Here we using with the flag contract name. The software will find inside the basically the pre-setup that you done in the registry file. It will find the contract and basically will deploy. So I'm gonna do the same using this key for deployment. Okay, contract not found. Okay, so we need to do the installation again because basically the binary already installed and we update, so we need to update the binary, so we need to reinstall. It's good that you see this right now, because if you was unfamiliar with this kind of error, so yeah, it's good. So again, the password. Okay, creation failed, address mismatch. Okay, this is good. So let me check again. Maybe I mess up with the salt number. So also you can see basically it's doing me like, okay, this is the address was computed, but basically we are expecting on this address. So it's not good. So let me check quickly. Okay, so what basically happens, so I did a small mistake. I'm using usually this Foundry script to print all things, or just if I need for some maintenance. So basically I printed the constructor arguments, and then I basically want to print the creation code. So it's already concatenating with the constructor, and this is the reason why basically it's not deploying with the address that I mined before, the vanity address. So let me set up quickly and we can continue from here. Okay, so I set up again the creation bytecode. Then let's go and try to run again the deployment. Okay, same command, same key. Yes, because we need to install the new binary. Okay, remember, you changing something in the source code in Rust, you need to reinstall and yeah, and install the new binary. Okay, now it's gonna be hopefully work. Yes, perfect. So we see the all connections again to the networks, then deployment, and the basically verifications. So here I just use with base Sepolia because I want you to see basically how I'm getting the information of deployment transaction that I can redeploy like literally the same contract without even storing all the stuff of salt and different things like pass to the contract. You literally can forget where's the all these things exist, and just using with the uh, deploy transaction and to deploy in any chain, and of course verify that. So let's see how it's working. All right, so let's go to the transaction that basically happens. So what I can do is just to take the payload of the transaction here and create another contract spec. And basically what we can do is next time already deploy without anything that we set up here, all fields, the address we need, but salt, then the path, constructor arguments, and the other fields basically we don't need. So Let me second to set up quickly and we can continue. All right, so as you can see, the only one field that I'm holding here, it's the deployed transaction, the one that I took from the real transaction here in the scanner. And what we're gonna try is to deploy in another chain before it was a base chain. And I will try, for example, to deploy in Arbitrum Optimism and basically to do the full flow and verification in Arbitrum. Okay, so basically the command supposed to be like that. Okay, that maybe you can see clearly. 1 second, I will do a little bit zoom in or zoom out. Yeah, now, yes, perfect. So the thing here that we need to add to the command the source chain, where is we already deployed that. We know the contract already deployed because we need to do a cross-chain verification with Etherscan. And yes, so basically we have the contract name is same as the same command before. Now I want to do deployment in Arbitrum Sepolia. And basically to verify the source chain, it's going to be base Sepolia because we already deployed there. So as you can see, basically what I've done here, it's I comment the object contract spec that I used before, basically that we set up all fields. And here I'm just using this same transaction that we deploy on the base chain, and I'm gonna use with the same contract name object. But right now I don't need to hold solc path to the contract and the arguments and creation bytecode. So it's basically will deploy same contract that was here. It will deploy with the same address in other chain. So you don't need to store or remember the other parameters. So let's go do the same key. And okay, we deploy. Okay, so this contract don't need right now to verify because it's already verified, and we can go and see in the scanner. So you can see it's the same address, totally same contract, similar contract that you basically can deploy without storing any of information that we stored before. And you can redeploy any contract that was deployed on the Deterministic Deployer proxy. So if I will go even here and choose any transaction of deployment here, just random transaction, and I will take this payload and will execute in another chains this payload. Okay, so it will deploy same address, same contract, same Solidity code in any chain that you want. So even basically you don't have the solc or source code. So if, for example, in a case of developer who left and he didn't documented everything, so you can go and see if basically this contract was deployed with with deterministic deployer proxy, so you can fetch the payload setup and the way how it's deployed here. You can deploy in any chain, and of course verifying that. Okay, we got to the end of the basically of the video. I hope everything is clear. If not, you can go all the time to documentation and read. And also I'm creating HackMD that will explain everything, include this video, and will show the full implementation parts and the commands that you need to work with. and the way how you can work, the flags basically, so all the stuff you have here to read and to make a easy engagement with this software. So I hope you find this somehow essential for your work. I'll be happy if you will use with this software or give some feedback. Of course, the software it's not audited and it's something experimental. Big thanks to the team of Paradigm that created amazing crate alloy. This package I'm using to do any engagement on chain, and for Foundry, of course, that helping somehow to verify part of the flow. It's using Foundry to verify smart contract on chain. So yeah, thank you very much, and yeah, hope you will enjoy to use it. Bye.